Yes.
I used to get spanked. I'm too old for that.
Well, yeah. I think
I get my mouth smacked.
Yeah.
I'm disrespectful.
Fair. Okay, so the last thing that we did before break was take a quiz over factoring. Okay, yes, we took a quiz. Okay, that quiz was all about factoring. What is the whole point to factoring? What are you trying to do? No. Well, yes, you have to do the greatest common factor, but what's the whole point? What's the goal in all of it? No. No. If I say, what are the factors of 10, what do you tell me? 5 times 2, right? Because you just determined the original multiplication problem. Do you remember us talking about that? Yeah, factoring is determining the original multiplication problem. Can you put your hoods down? That's bothering me. Thank you. So in algebra, normally when we multiply, how do we show multiplication? Parentheses, right? We know that parentheses indicate multiplication, which is why we make parentheses when we factor. Fair enough? Yes? Okay, so remind me, what's the very first step when we factor? Yep, the first thing you look for is a GCF. Guys, that will never change. GCFs are helpful because if you take out a GCF, then it makes your numbers smaller. Good? Then if there's 4 terms, I taught you to do a specific type of, grouping. If there's 4 terms, we group them, and we group them 2 by 2. Does that ring a bell to you? Yes, it should. Then, if there's 3 terms, this is where you come in, Tyler. We did a binomial times a binomial. And you notice there's a B here because all of these problems that we did a binomial with times a binomial start with a 1. Okay? Every problem that we did always started with a 1. For example, and please don't write this. Does that start with a 1? The leading coefficient out here would be a 1, wouldn't it? Yes? How about that? Does that start with a 1? It does. All of those problems started with a 1. And then you had to ask yourself, what factors of 9 will add to 10? Still ringing a bell to you, right? What factors of 56 will subtract to 1? Still ringing a bell to you, right? Okay, well, of course, they're not always going to start with a 1. So we have to have a way to do them if they don't start with a 1. And if you look at your problems down there at the bottom, none of those start with a 1, do they? So here's where this method comes in. It's called slide and divide. So this is what we're going to be learning today. Slide and divide. Okay, and we are going to use this if it does not start with a 1. Okay, we use slide and divide if it does not start with a 1. Okay, so I have 4 steps that we're going to do for slide and divide. You guys see how I listed them down there? 1, 2, 3, 4? Do you see how there's a problem that 4x squared, I think it's minus 12x plus 9? Do you see how it's right next to that? So I need you to keep all of your writing over to the left, and then we're going to work out that problem on the right. Good? Okay, so first things first. You need to slide the leading coefficient to the end and multiply. Slide the leading coefficient to the end and multiply. Again, keep all your writing to the left, please. Okay, so are you ready? What's my leading coefficient over there? So I'm going to take this number and I'm going to slide it all the way to the back and I'm going to multiply them. What is 4 times 9? So now my problem is x squared minus 12x plus 36. Do you see how I took it from the front and put it to the end and multiplied? Yes? Now, this thing starts with a 1 now, doesn't it? Don't we know how to factor things that start with 1s? Yeah. And how do we do that? Well, what do we call that? What are we making? Nope. Factor by a binomial times a binomial. Tyler, isn't that what you just told me a couple minutes ago? Yep. If it starts with a 1, we're going to do a binomial times a binomial. Okay, good. So let's make these binomials. Guys, what do your binomials need to start with in this case? Good. And in your head, you're looking for factors of 36 that add to 12. What you got, Derek? 6 and... Does everybody agree that 6 times 6 is 36 and 6 plus 6 is 12? Yes, we're all good there. Now, did this symbol right here tell me same or different? Same, and they both have to be subtraction. So there we go. We factored it as if it started with a 1, but did it really start with a 1? No. So your next step is going to be divide by the original leading coefficient. Divide by the original leading coefficient. What was my original leading coefficient? 4. Now, folks, 4 is a number, isn't it? So we're going to take the number portion of these and divide by 4. Only the numbers. Okay. Does 6 divide by 4? What? 6 does not split into 4 pieces, does it? No, but will 6 over 4 reduce? What will it reduce to? No. Okay, now I just want it to still be a fraction. Reduce it down to 3 over 2. Do you all agree that 6 and 4 are both divisible by 2? Yes? 6 divided by 2 is 3, and 4 divided by 2 is 2. Is everybody okay with that? Now, this just so happens that both of these are the same. This is just a coincidence. They won't always both be the same. But obviously 6 over 4 is 3 over 2, right? Is everybody okay with that? Now, do you agree that this is kind of not very pretty looking? Because of that fraction, right? We're going to get rid of the fraction. In order to do that, I got to get rid of this bottom number. Now, what is this bottom number called? Denominator. So we are now going to slide the denominator to the front. Slide the denominator to the front. So this 2 right here is going to be slid right in front of there. And obviously this one's going to do the same thing. Do you agree that this is normally what we like them to look like? Yeah. And does this look like the original multiplication problem? Sure it does. These parentheses mean multiply, don't they? If I wanted to check this, I would chop it in half and distribute and hope that I get that original problem up there. How is this for everybody? It is long, okay, but it's a step-by-step process. We ready to try again? Yeah? Okay, let's look at number 1 down there. Does this thing, well, first of all, we always got to look for a GCF. Do I have a GCF? 2, 7, and 9, can they all be divided by the same thing? No, they can't, okay? And unfortunately, it does not start with a 1, does it? So we're going to need to slide and divide. First things first, we got to slide this number back here, and we're going to multiply that. You get 18. So the new problem is now a squared plus 7a minus 18. Do you guys see how I keep the same symbol on the 18 that was on the 9 before it? Okay. Now it does start with a 1. So in your head, I'm saying, okay, if I'm going to factor this thing that starts with a 1, I got to make a binomial times a binomial. And what am I going to start that with? A. In your head, you're asking yourself for factors of 18 that will subtract to 7. And Tyler is telling me 9 and 2. Is everybody okay with 9 and 2? Yes? What does this symbol right here tell me? Different. And the bigger one has to be positive. So that means the 9 is positive and the 2 is negative. Now, folks, it didn't actually start with a 1, did it? What did it actually start with? So we're going to take these two numbers and we're going to divide them by 2. Does 9 divide by 2? It does not. Does it reduce? Does 9 over 2 reduce? Can I divide 9 and 2 by the same numbers? I can't. So we're just going to leave it as 9 over 2. How about 2 over 2? Does that divide? What is 2 over 2? It's just 1. Now, this first parentheses does not look the way I want it to look. Do you see this denominator? What am I going to do with it? Slide it to the front. And now, this looks like the type of problem that we would usually see. Doing all right? Yeah? Okay, I'm skipping number 2 and going to number 3. Okay. First things first, is there a GCF? Can I divide 3, 5, and 12 by the same number? No. Does it start with a 1? It does not, so let's make it start with a 1. Slide this guy to the back and multiply. What do you get? So my new problem is d squared plus 5d minus 36. Now it starts with a 1. How do I factor trinomials that start with a 1? Binomial times a binomial. What are these binomials going to start with? D's. And in your head, you're looking for factors of 36 that will subtract to 5. What factors of 36 will subtract to 5? 9 and 4, he says. Now, Dylan's really good with his multiplication facts. Folks, if you don't know that, you're going to have to pick up your calculator and start trying some numbers till you find something that works. Good? Luke, how you doing back there? All right, what does this symbol right here tell me? Same or different? Different, and the bigger one has to be positive, so it's going to look something like that. Now, folks, it didn't really start with a 1, did it? What did it start with? So I need to take that 3 and divide both of them by 3. Does 9 divide by 3? Yeah, it is. What is 9 divided by 3? Okay, how about 4? Does that divide by 3? Does 4 over 3 reduce? It does not. So I'm going to leave it as 4/3. Now, the first one is just fine. It's nice and pretty for us, isn't it? Yeah, that one's going to stay. What am I going to do with this denominator? We're going to slide it to the front. Whoops. And that looks like my final answer. Is everybody all right with this? You sure? As long as you can repeat this process, you'll be just fine. No, I told you we're not going to be doing them all, didn't I? Didn't you hear me say that 4th period had extra credit? Yeah. Yes. Okay, we are going to do number 4. First things first. Does number 4 have a GCF? What is it? 2. All of these can be divided by 2. So the 2 goes all the way out front. If I divide them by 2, what do you get? And that's e squared, right? Minus. Good, and that's an e. Plus. Now, folks, do you see the trinomial that's in the parentheses? That's what I'm concerned with. This 2 out front, I am going to pay no attention to until I get all the way down to my final answer. Is everybody clear on that? Okay, does this trinomial start with a 1? What does it start with? It starts with a 4. So we need to slide it back there and multiply it. If you slide it back there, I now have e squared minus 12e. What is this number going to be? 20. And now it starts with a 1, doesn't it? Okay, so I know if it starts with a 1, I'm going to do a binomial times a binomial. And what is that binomial going to start with? E. And in your head, you're asking yourself for factors of 20 that will add to 12. 10 and 2 is correct. What does this symbol here tell me? Same or different? Same, and they both need to be, subtraction, negative. Is that okay? Now, guys, this thing actually didn't start with a 1, did it? What did this trinomial start with? A 4. So both of these things need divided by 4. Does 10 divide by 4? No, but it will reduce. What can I divide both 10 and 4 by? 2, so this will become 5 over 2. Is everybody all right with that reduction? Okay, how about 2 over 4? Does that divide? No, but it will reduce. So it will reduce to 1 over 2. And these things don't look the way we like them to look, do they? So what am I going to do with this denominator? Slide it over. So this will be 2e minus 5 and 2e minus 1. Now, does everybody see how the 2 GCF is now in my final answer? You can't forget to bring that all the way down. And that's the original multiplication problem that would have made the trinomial at the very, very beginning. You all right, Tyler? Yeah. How we doing, guys? Do you feel like you could duplicate this on your own? Not yet. We'll do a few more, but do you feel like this is something eventually you can do on your own? Okay, let's do number 5. How did I do giving you enough room? Did I give you enough space? You all right? Is there a GCF in number 5? Yeah, there. Oh, no, there's not. I can't divide all of them by the same number. Does it start with a 1? No. So we're going to take the leading coefficient. We're going to slide it back here. What do you get? So that'll be a minus 48 now. Because now it starts with a 1, I can now make my 2 binomials. And I'm going to start them with f. In your head, you're asking yourself for factors of 48 that will subtract to 13. Factors of 48. So grab your calculator. 48 divided by, and start trying some numbers. And I want 2 numbers that will subtract to 13. 16 and 3. Wonderful. Folks, does this minus sign mean same or different? And this one means the bigger one has to be positive. The 16 is bigger, so that one is now plus. Now, folks, did this actually start with a 1? What did it actually start with? So I need to divide both of them by 2. What is 16 divided by 2? Does 3 divide by 2? It does not. Does it reduce? Does 3 over 2 reduce? The only thing I can make it is 1.5, and that's not really reducing it at all. Okay, the first parenthesis is A-okay. What's your second parenthesis going to be? 2f minus 3. Does everybody follow what Savannah's doing there? That denominator is coming to the front. Okay. What's up, Dylan? You okay? Everybody good? Want to try another one? I think I'm going to do, let's do 2 more and I'll be done. Promise. Okay. Okay. Number 6, first things first, is there a GCF? There is not a GCF, and it does not start with a 1. So we're going to take that leading coefficient, and we're going to slide it to the back and multiply. What do you get back there? So now this is going to be 30h squared. It starts with a 1, so I'm going to make my 2 binomials. What do they need to start with? What do they need to end with? They need to end with h. Do you guys see how there's an h squared on that last term? So they also need to end with h. In your head, you're looking for factors of 30 that will add to 17. 15 and 2. I know. Now, does this symbol mean same or different? Same, and they both need to be negative. Now, it didn't actually start with a 1. What did it actually start with? A 5. So these things need to be divided by 5. Does 15 divide by 5? Yes, it does. You get a 3, and of course, there'd still be an h on there. Does 2 divide by 5? Does it reduce? No, it does not. Okay, so the first parenthesis is A-okay. What will the new second parenthesis be? 5g minus 2h. And that is your original multiplication problem. Fair enough. One more. We'll call it good. Number 7. Nope, I lied. I know, it's not a good thing, is it? Let's do number 9. Number 9. It does not start with a 1. Hold on a second, though. You forgot to ask yourself about a GCF. But did you see how it starts with a negative? Guys, I don't want it to start with a negative either. So we are going to divide all of these by a -1. That's going to be our GCF in this problem. We're taking out a -1. If you take out a -1, what's left? No. 3k squared minus 22. Do you guys see how you're basically just changing the symbols on all of those terms when you divide out a negative? Okay, does it start with a 1? Oh, no, it doesn't. So we're going to take this thing. I should have rephrased that. I didn't ask that very well. The parentheses does not start with a 1, does it? It starts with a 3. So we're going to slide this to the back. Now, folks, remember, this -1 means nothing to me until the very, very end, okay? When you slide that back there, I get k squared minus 5k. What do you get right there? -66. So if I make my two binomials, what are you going to start them with? And you're asking yourself for factors of 66 that will subtract to 5. What factors of 66 will subtract to 5? Wonderful. Does this symbol mean same or different? And this one means the bigger one has to be, so that means the 11 is negative, the 6 is positive. What did it actually start with? A 3. Notice I did not go back up to the original. I went right here. So these things need to be divided by 3. What is 6 divided by 3? So this is actually k plus 2. Does 11 divide by 3? Does 11 over 3 reduce? Can I divide 11 and 3 by the same number? I cannot. So it looks like my first parenthesis is just fine. What is my final second parenthesis going to be? Wonderful. And this is now the original multiplication problem. Okay, so you've got plenty of work on there if you want to, well, some of you need to get some extra credit for not turning in your mountain math. Okay, but there's plenty there. Please don't do it on the sheet. Do it at the end of your homework. I'm not collecting this note sheet. Okay, do it at the end of your homework. That is your homework.